तो स्टूडेंट्स डिजिटल टू एनालॉग कन्वर्जन की बात चल रही है। 3 टेक्निक्स हम लोगों ने स्टडी की थी। द फर्स्ट वन वाज एम्पलीट्यूड शिफ्ट कीइंग, देन वी हैड द फ्रीक्वेंसी शिफ्ट कीइंग एंड देन वी हैड द फेज शिफ्ट कीइंग। अब स्टूडेंट्स आप लोगों ने गौर किया था कि इन एवरी सिंगल वन ऑफ दोस टेक्निक्स व्हाट वी डिड वाज वी वेरीड वन कैरेक्टरिस्टिक ऑफ द एनालॉग सिग्नल। In the ASK, we varied amplitude and kept the frequency and phase constant. FSK, we varied the frequency and kept the amplitude and phase constant. And in PSK, we varied the phase and kept the amplitude and frequency constant. Now, students, we need to go to our 4th technique for the digital to analog conversion, and that technique is QAM or Quadrature Amplitude Modulation. Students, before we discuss QAM, I need to brief you on a specific concept that we are going to be using in QAM, and that is the concept of Constellation Diagram. Now, students, Constellation Diagram helps us define the phase and amplitude of a signal element. Students, this is especially useful when we are using 2 carrier frequencies, one in phase and one in quadrature. Students, गौर कीजिएगा, जब मैंने आपको क्वैम की बेसिक इंट्रोडक्शन दी थी तो मैंने आपको ये बताया था कि क्वैम कंबाइंस एएसके एंड पीएसके। एम्पलीट्यूड क्वाड्रेचर, पीएसके इज फेज। तो क्वैम के केस में अपने सिग्नल एलिमेंट रिप्रेजेंटेशन के लिए एंड टू लुक एट द डिफरेंट प्रॉपर्टीज और कैरेक्टरिस्टिक्स ऑफ दोज सिग्नल एलिमेंट्स, वी नीड अ डायग्राम विच इज कॉल्ड एज अ कॉन्स्टलेशन डायग्राम. Students, as I told you, signal element in this diagram is represented as a dot, and normally the number of bits that it's carrying is actually, and the bits that it's carrying, it's actually listed right next to this dot. In the slide, what you can see is we have got a constellation diagram for BSK, BPSK, and QPSK in the bottom. On the top, it is showing you what this constellation diagram is made up of. Students, the diagram has 2 axes. The first axis is the y-axis, and the y-axis represents the quadrature carrier. So as you will see, it will represent the amplitude. Then you have the x-axis, which represents the in-phase carrier. Now students, ये जो signal element है in this constellation diagram, the constellation diagram for this particular signal element gives us 4 distinct pieces of information. Students, first of all, the position of the signal element on the x-axis, it gives us the amplitude of the I component or the in-phase component. So the first information that we get from the constellation diagram about this signal element is the amplitude of the I component. Students, the positioning of the y-axis, it gives us the amplitude of the quadrature component, the amplitude. Number 2. Students, the line from the origin to the signal element is, or the length of this line, it gives us the amplitude, the peak amplitude of that signal element. So that's number 3. And students, the angle that this line makes with the x-axis, this gives us the phase of this signal component. अब students, हमने binary ASK और on-off keying, binary PSK और बाइनरी फेज शिफ्ट कीइंग और क्वाड्रेचर पीएसके, हम लोगों ने ये 3 टेक्निक स्टडी की थी. और in the bottom part of the figure, what you can see is we have got constellation diagrams for each one of them. For the first one, for ASK, we are using only an in-phase carrier. Therefore, the students, the 2 points that you have on the constellation diagram for ASK, it is a binary 0, which is at origin. It's an amplitude of 0 voltage, and then you have a binary 1, which has an amplitude of 1 volt. Students, BPSK, same thing. We are still using an in-phase carrier. However, in this case, we used polar NRZ signal, if you remember. Therefore, it carries 2 types of signal elements, and we can say that one has with an amplitude of 1 volt, and it is in phase, and it's represented by a 1, and the other one has got an amplitude of 1 volt, and it is 180 degree out of phase. So the first one, and this is the second one. Now students, for Qpsk, As you know, Qpsk uses two carriers. Quadrature phase shift keying uses two carriers, one in phase and the other one quadrature. So the point representing, for example, 1, 1 in this case is made up of two combined signal elements, both with an amplitude of 1 volt. One element is represented by an in-phase carrier, x-axis, and the other element by a quadrature carrier. We have got our y-axis.